The Green Roads webinars are anchored in ADB's Green Roads Toolkit and Assessment Tool, which is available from ADB's library. And today's webinar will focus on the topic of digital tools for advancing rural transport access. Our next webinar will be on February 13 and will focus on ADB's Build Back Better guidance that was released in late 2024. And following that, on February 27th, we will look at the latest thinking around bioengineering for delivering climate resilient infrastructure. After the webinars, we upload the relevant materials to the Green Roads webinar website, which we will share with you as well in the chat box. Today, we will have two speakers, and I'd like to remind you that you may place those questions at any time during the Q&A box, and we'll answer them in the Q&A session after the presentations. So without further ado, I would now introduce you to our moderator for today's session, Dr. Ian Greenwood. Thank you.
Thanks, Rebecca. And it really is a pleasure to be back here again for what I think is going to be a wonderful start to the 2025 webinar series. The ADB and others like the World Bank often focus on the construction of the major transport networks of the world. We also know, though, that it's often the last kilometre or the last mile where many struggle to connect to the transport networks, or where short within-village trips become unnecessarily difficult. People can't access schools, health facilities, or markets or similar. And while living within 2 kilometres of an all-weather road, aligns with the UN sustainability goals, Sustainable Development Goals, it doesn't truly reflect rural isolation and challenges where terrain, rivers, and other barriers actually preclude making use of that all-weather road. Now, the Bridges to Prosperity team that are here today, they recognise those issues and have been busy not only building in excess of 500 trail bridges around the world, but also in developing a suite of technology tools to help identify the optimal location for those bridges and also the actual impact on the communities. I like to simplify it to say that they build bridges to build better lives to the rural communities, but they use technology to actually pick the right sites and demonstrate the benefits. Really interesting talking to them to date, and we've got two very interesting speakers. First is Erica Brandt, who's the Director of Strategic Partnerships at the Bridges to Prosperity, holds a Bachelor of Science, Master of Science in Environmental Civil Engineering from the University of Colorado, Certified Project Management Professional, worked on various projects all around the world, and now based in Kenya, where she leads the efforts to actually collaborate with governments and development partners to make a real impact. And following on from Erica is Cameron Cruz, who's the Director of Digital Technologies. He leads all their technical development, including the development of the software called the FICA map, which helps them actually identify these sites and do all these impacts. Very interesting background in machine learning and map storytelling. I guess the more interesting part is he's also an explorer with the National Geographic, has led expeditions, produced films and essays and the like. So 2 wonderful speakers, and again, just reiterating, please ask your questions in the Q&A box. We'll get back to them later on. And for now, the floor is yours, Erica and Cameron.
Great. Thank you so much, Ian and Rebecca. Team. We're really to be with the story. I can't tell if that's my internet or Cameron's. There we go. You're moving again.
Hey, thanks, Erica. It could have been my internet. You were breaking up.
Can you hear me now,
yeah.
Cameron?
I got you now. Yeah, but okay. I'll quickly introduce
myself.
Well,
then let me just repeat, just thanks to everybody.
Perfect. Yeah. Quickly introduce myself. Director of Digital Technology here at Bridges to Prosperity. I swear we practiced this beforehand and it was all working. but hopefully the internet holds throughout. It's a constant challenge across the world as we do this. Erica's going to present the first half of our content, and then I'm going to jump in later in the presentation and talk about some of the digital tools we've built to support our work here and give some live demos. So with that, I'll hand it back to Erica.
Great. I'm not seeing our slides, if you don't mind putting them up on the screen.
Absolutely.
Great. Thank you, Cameron. And thanks, everybody. Really excited to be here today to take you through B2P, Bridges to Prosperity's approach to looking at rural access, and to specifically dive into developing to support rural transport planning and waterway map.
Sorry, Erica, you're breaking up a bit. Maybe stop sharing your video and just keep the audio.
That's a little better for now, Erica. Why don't you give it a shot? And if not, you can change your Wi-Fi and I'll present the first few slides.
Cool.
We
I'm
can
seeing
hear
still
you
the
now.
title slide. Great. So today we want to take you through information about the gaps and barriers to rural transport networks around the world. Talk about Bridges to Prosperity's approach to make rural connectivity easier and more cost-effective. And then we'll take you through a demo of FECAMAP and what the digital tools we've been developing. And we'll definitely leave time at the end for Q&A with the audience. So B2P is a nonprofit organization, and we exist because of this issue, that globally 1 in 7 residents can't reach essential services like markets, jobs, schools, because of gaps in their transport networks. So you can see from this video an occurrence around the world, a community hand crossing of a river, small wooden, and in the rainy season, it will get washed downstream every year and create accessibility challenges. And
Erica, hey, Erica, I'm going to jump in here. I think it might be best for you to switch your Wi-Fi. And I'm going to jump in and share a few slides in the meantime.
Let me try that.
Thanks, everyone, for bearing with us on the technical difficulties. So as Erica was saying, we exist to solve the problem we saw in the last slide, which is connectivity issues. And we found that rural isolation in communities is a root cause for poverty. And we've done many studies on this. And our organization was founded on the premise that if we can solve some of these connectivity issues for these rural communities, we can help the people that are most vulnerable, women, girls, people with disabilities, and the elderly. As we've done this, we've seen, and I think we're speaking to the choir here, that transportation investment is often funneled into urban and national projects, which makes sense. This is where a lot of people live, and this is where a large impact can happen. But I'm going to hand it back to Erica to give us more of a rundown on how we do this. I think we have her Wi-Fi back.
Yeah, thanks so much, Cameron. I'll keep off video just to try, because now I'm hotspotting. But yeah, that's true, Cameron, that there's a disproportionate investment into more urban projects. And even those urban or national projects have communities around them that can't reach those new facilities, those new roads, because of a lack of connecting infrastructure. So as an organization, as a nonprofit, we're really trying to bring down barriers to that investment. And We've worked in more than 20 countries around the world. And just to summarize, I think these are some of the barriers that we see of why there's not enough investment in rural transport networks, despite it being such a root cause of poverty and such an impactful issue for many communities around the world. The first is that governments around the world have limited budgets, and associated with that, competing priorities. So when they're comparing different projects that they might want to invest in, they often use metrics like population density to prioritize those projects, which, again, like Cameron said, makes sense on some levels, but unfortunately, it continues to leave poor and marginalized communities behind. So it's not a totally sustainable solution. There's also perceived inefficiencies, a higher cost, and high maintenance needs. If you could just go back one slide, Cameron, associated with traditional methods to improving rural transport networks. And so really that's because decision makers don't have a range of solutions, especially solutions that are cost effective and climate resilient, at their fingertips. So if they're using traditional methods for how they normally improve roads and look at development in that way, it is going to be very expensive and inefficient sometimes, and have high maintenance needs. So they really need a different set of solutions for rural areas. And finally, we found that the most rural roads, rural trails, and waterways are often unmapped and unreported. So really, those decision makers don't know the scope of the need or have rural projects ready for investment. And this is really a challenge. Next slide, please. This is really a challenge because we know rural transport development is really critical to meeting our SDG targets. Transport is connected to so many different issues. And it's really important to be able to address the end of rural poverty on any meaningful timeline. We need to be able to look at the interconnectivity of these issues, because transport affects climate resilience, it affects market access, food security, health, livelihoods, education. All of that requires functioning transport networks. So if we're looking at transport network development, focusing on spot improvements have been shown to be a particularly cost-effective, sustainable, and impactful methodology to look at and deal with rural transport issues differently. So we've been really working with researchers around the world to kind of dig into this approach of rural spot improvement. We've just wrapped up a randomized control trial in Rwanda, and we're seeing massive transformational impact across the board for this kind of an approach, where we're seeing 75% increase in farm profits. We're seeing improvements to school attendance for girls, increases in vaccination rates, household income, and more. So it's really multidimensional, transformational impact with this kind of low-cost intervention. So again, we're a nonprofit organization, and we partner directly with governments and development partners like ADB. And our goal is to make it cheaper, easier, and more sustainable to solve bottlenecks in the rural transport networks. So I'd like to take you through how we do that as an organization. The first way that we do it, and again, kind of going back to the barriers that we talked about, one of those barriers being that decision makers don't know the scope of need, don't know the location of those needs in rural areas, and that rural roads, trails, and waterways are unmapped and unreported. So we want to come as an organization and help quantify and map the need and the impact of rural transport investments. So we do some field-based needs assessments, but we're also trying to make that faster and more scalable, because field assessments do take a lot of time. And across the world, there's a major data gap here. So we're also developing FICA Map, which is a tool suite using machine learning technology and remote sensing data, and is trying to identify both the scope and distribution of transportation barriers at scale, and then be able to estimate the cost and social impact of addressing those barriers. So Cameron, a little bit later in this presentation, is going to demo those systems and tools for us later. The next way that we work as an organization to make it cheaper, more sustainable, and cost-effective is to develop and standardize a suite of options for decision makers. Like I said, addressing rural transport networks in the same way that governments look at more major road networks is inefficient and cost effective, and that can be a barrier. So we are putting together a suite of different options for spot improvements of rural transport networks. And we really focus on options that governments might not be using as often, but really focusing on what is cost effective, climate resilient, low maintenance, and labor-based. And we take those technologies, those options, and we iterate them to be widely applicable to different topographies and site conditions. So it's really easy to roll them out at scale without a lot of redesign work at each location. The next way that we work is to help institutionalize those effective solutions, both within government and also to build up the local private sector. So if we know where all of the areas of challenge are in the rural areas, and we have a suite of different technologies, then we just need to ready the local partners to be able to address those issues. We also, as an organization, do the designs and construction sometimes ourselves, but we really try to also build up small and medium enterprises in the countries that we work to be able to deliver these solutions at scale as well. So we put together lots of different tools that are adaptable to local contexts. And we work together with local partners on that. So everything from our standard designs and drawings, but also different manuals, training materials, policy options, comparison tools, to really, again, make it as easy as possible for these projects to be rolled out at scale. And the last way that we work as an organization is to support innovative approaches to this kind of programming. So sometimes we'll work with partners on standalone rural access projects, but sometimes we work with government and development partners to combine rural access onto other types of projects to help planning and programming be more holistic and cross-sectoral. So I'll take you through a few of the different ways that we've worked recently to kind of highlight these approaches. The first being a project with African Development Bank and the Uganda National Roads Authority. They were working on a large road project, an economic corridor project. And this project went through, this road went from Kenya to Uganda to DRC. And they were working on a section of the road from Uganda going up to the Kenya border. And they were seeing that there were a lot of rural communities around there that were not able to access that road. And again, this is an economic corridor project. There's a lot of produce movement between the countries and to different areas of these countries. And so we really wanted to increase accessibility. So we supported the partners to look at the area in the kind of corridor around that new road, identified the most critical access points where rural residents couldn't reach the new road, and came in to do spot improvements to address accessibility issues. The next example was in Côte d'Ivoire. We worked with the Millennium Challenge Corporation and the government there to look at really the education sector. They were working together to improve education outcomes in a number of different ways by building new schools, improving older schools, and they were finding that school attendance was really down in a lot of areas, and especially during rainy seasons, accessibility was an issue. So we came in to do assessments and help them identify, in the kind of catchment areas of those schools, where were the access issues, and where could spot improvements be applied to ensure that accessibility wasn't impeding school attendance. Another example is that we are currently working with the government of Uganda, with actually 6 different government agencies, all having kind of different mandates and different pieces of the work dealing with the rural road network in Uganda, and recognizing that these partners are having challenges to get the rural road network where they want it to be. So we're bringing all the stakeholders together with civil society to really work on the strategies, policies, and systems that the government needs to tackle the rural road network in a very different way, to bring in lots of elements of sustainability and climate resilience, making planning and budgeting more efficient, and so really trying to transform the way they approach the kind of start to finish the rural road network planning, management, building, and funding. So I'd like to hand it over to Cameron. I've tried to paint a picture for everybody about how we're trying to bring down those barriers, how we're trying to work as an organization to make it more sustainable, more cost effective, to address rural road issues. So if you remember, the first way that we work as an organization to help quantify and map that need and the impact of rural transport investments, we are developing some digital tools. So yeah, let me turn it over to Cameron now to take us through more information about those and give us a demo about those systems.
Thanks, Erica. Yeah, so our digital programs here at Bridges to Prosperity are really focused on that word scale. You heard Erica mention it a few times, but that's really why our digital programs are in production right now. And everything we build in every digital product we build is meant to scale our services in some way. We have the studies to show how impactful overcoming transportation barriers are to rural communities. And we really feel that the next step is how can we scale this from Bridges to Prosperity, building these bridges, to empowering many governments and large organizations around the world to build the infrastructure that will connect these communities to their critical infrastructure. And Erica talked a lot about how we're doing that, working with partners, how we're doing that, working within programs. But how can we make this faster, easier, and more efficient? So that's what I'm really going to focus on in this conversation. So when the program we call FICA Maps, that was the origin of our digital programs, when that started, it started as a quest to solve or answer 2 questions. Can we predict bridge locations at scale? And can we predict bridge impact at scale? So what this would look like is, can we look at an entire country, an entire region, and maybe the entire world and predict where bridges might be needed just by looking at data like remote sensing data or satellite data, or collecting it from local communities? Furthermore, can we model the impact that these bridges would have on these communities, and then connect that to help decision makers prioritize the most important infrastructure? So those were our 2 original questions, and we've been trying to answer those over the past couple of years. And as with any good questions, we really discovered more important questions. And what we really found was, we are strong believers in people want to solve problems they can see. And rural communities around the world are often invisible, particularly when you look on maps. And I'll get to that more in a second. But we found that many of the questions, just the two questions we wanted to answer, had deeper questions around. We didn't really know, we don't have a strong sense of where rural poverty exists right now. Only some of the barriers that these communities are facing are really mapped or known about, particularly at scale. Where people need to go, where are the schools, where are the hospitals, where are the markets? Those aren't really known and mapped often. And what exactly is the infrastructure, whether that be trail bridges, roads, paths that are needed to connect these communities to this infrastructure? So we went deeper and started to try to answer more of these questions. That meant more than just developing one model or one data set. And so what I want to do over the next 15 or so minutes is really walk us through our journey, what we've learned, and also share the data in visual formats and ways that you all can access as well as we go through this. So the first data gap that I want to focus on, right? That question of, people want to solve problems they can see. We often can't see the barriers that are impacting rural communities. In some countries, more than 60% of our bridges that are built, so these are bridges that have been built over waterways, sometimes 60% of those bridges were on unmapped waterways. And let's just take a moment to let that sink in. Imagine the river or the water body closest to your home where you live. Imagine that not being on a Google Maps. Imagine that not even being such an unknown barrier that it's not even on the map that people use to identify where the transportation infrastructure is needed. So as we saw this to be our one of our primary problems is the fundamental barriers that we're focused on aren't on maps. So what I'm going to do here is I'm going to take over the screen share and share a demo. But what we worked with a group called, and here's a slide illustrating what I just said. You can see the red dots where we built bridges, and the green lines are the mapped waterways. So many of our bridges are on unmapped waterways. Scientists went and they said, oh, we can use AI to better map waterways. And they did. And that's what you see in the brown lines. But still, many of our bridges are not even on these AI identified waterways. And so we took our own stab at this with a research group out of CU Boulder, Better Planet Lab. And we worked with them and used our data that we have and their expertise to develop a custom model that we deployed worldwide. So this is looking across the world, not just in the 20 or so countries where we've built bridges. It's looking worldwide for waterways. And we designed an AI algorithm that's actually tripled the amount of mapped waterways around the world. So what you see in blue here are our mapped waterways with our custom algorithm. And then again, the green and the orange are previously mapped. But I really want to show you the scale of this. I think this is important. And I really want others on this call to be aware of this new data. And we make this available in very visual, very accessible format. So this is a map of Africa, as you can see. And what I have visualized right now is anywhere you see blue is a previously mapped waterway. Anywhere you see yellow is a waterway that was previously not mapped, but we have now mapped it in our data set. This is an interactive map. As you can see, this is a worldwide data set. But I want to zoom into, let's just zoom into one area here. Let's look at Madagascar. If you zoom in here, you can see many of these waterways. Again, the yellow ones are the newly mapped ones, have not been mapped. If you can turn this into a 3D visual here, you can really start to see where these waterways go, and it starts to make sense, some of the topography of the land. Yeah, again, all these yellow waterways are new. Many of our bridges are built on these small tributaries. Even if a river only floods 5 days a year, families don't send their children to school. Families don't grow crops they can sell at markets because it's too risky. So even the smaller rivers that are unmapped can have large impacts, is what our research has shown. So we have this data available. We'll try to share out some links after the fact, but you can find on our website where you can access this. We've open sourced it all. So if you have a need to work with waterways data, we just released this on the cloud in a very accessible way. And you can read more about the work we did to build this AI model. And you can also just explore it. I think it's really beautiful when you go into areas like the Amazon or these other rural areas where just the breadth of this work really comes through, and you can just see how much, how many waterways are really around the world. All right, so I'm going to step away from this for a moment and go back to the slides and go back to this question around the core mission of what our program is doing. So now we know where waterways are. That's great. We can use those as like a magnifying glass in a way to predict where the barriers might be for someone to access critical infrastructure. But then begs the question, okay, where are people walking to get to this infrastructure? The trails aren't mapped. Almost none of the trails that the rural communities we work with that they use are mapped. Not even all the roads that they drive vehicles down are mapped. So we had to design our own walking model, or walking path model. And what this is pretty straightforward. We take where we know people to live, and then we take the destination that we predict, and our walking path model fills in this gap in a couple ways. So the first way it does this is it will look at the topography. So you look at the digital elevation model of the landscape and predict the most efficient path for someone to walk. It then imports all the data we do know about roads, paths, other types of transportation infrastructure, and predicts where someone might walk using that infrastructure as well. And then it takes into account some other information about barriers. So if you see somewhere to be a cliff, if you see somewhere to be a river, we know where those are now. We take those into account as well and develop a path or a route. And this route is what we use in our walking time model to predict where someone might walk to get to a destination. But that's only half the answer. The other half of the answer is how long it takes someone to walk. Because what we really want to do when we predict impact is measure the time it takes someone to get to a destination. But then we run this again, but with the bridge over the transportation barrier. So now we're looking at how long it takes somebody to go with a bridge and how long it takes someone to get to a destination without a bridge. And that's the fundamental part of our impact model. So remember this dotted line. I'm going to show you a live demo of a prototype we have live right now, and it's our FECA map prototype. So I will show you this, and I'll come back to the walking path model in a moment, and I'll show you that here. So I'm going to I'll explain the colors in a minute, but first let's just look at this community. So every hexagon is a land base. So imagine a cluster of people, a group of people live in this area. And when you see the dots on the map, the blue dots are bridges. So this is a bridge we built in Rwanda. The orange dots are education facilities. The red dots are healthcare facilities. So let's look at this community here. If you click on this, you see the dotted lines pop up. I'll explain what's going on the right side in a minute. So you look at the dotted lines. Those dotted lines are the travel paths we've generated with our algorithm. The dotted blue lines here are the waterways we've developed with our algorithm. We know some of those are the barriers. You can see this bridge is built over this waterway we've predicted. This red line is a path to what I'm guessing is a hospital. Let's hover over that and see. You have the district hospital. And what we want to see is the time it takes to walk to that hospital. And it looks like it might take this community about 4 hours of walking time to get there, which is not great. But there's not a lot of hospitals, and so that's not unusual necessarily in Rwanda. But this is so that now we have the paths, we have our predicted travel time to these locations. How can we measure impact? We want to get a view of where maybe new bridges could impact communities, or which bridges are the most effective impacting communities, reducing their travel times to critical infrastructure. So you can actually change, and that's what I was showing before, and look at this on a nationwide scale here. So if you look at Rwanda now, the green areas are where travel time, we're looking to the school category right now, where travel time to school is quite low, what we consider to be an acceptable range. We don't consider this population that lives within this hexagon in Kigali to necessarily be dissuaded from going to school due to travel time. Now, if you look at some of the other areas that are impacted, so let's say this red area here, we predict this primary school journey might take close to 3.5, 4 hours, which is not great. There's probably not a lot of kids walking to their closest primary school. You know, if you live in this area, and we can see that many people do, and that they are in one of the, maybe the 8th percentile for walking time across Rwanda to school. So that's not very good. So this is, again, part of the answer to the question. We know how long it takes people to walk, but where are bridges making an impact? So we've built many bridges across Rwanda, so we have good data on where impacts are being seen by bridges we've built. And this is where the panel on the right is going to get really interesting. So I want to pull up a good example here. And we'll be able to look at this. Okay, so let's maybe this one here. There we go. Okay, so you can see this community, we consider it's in the green, is highly impacted by bridges in a good way. And you can see the travel paths we predict they take to the different destinations. But what we really can check out, and what's really interesting, is we can look at how much time this bridge saves them from traveling to a primary school or any destination. So we can see, if you look at this spider graph on the right, without a bridge, it would take 2 hours to travel to school. With the bridge, it takes about an hour of walking time. Without a bridge, 90 minutes. With a bridge, just over an hour of walking time. So it still could be improved, but there is, you know, maybe a 40% increase or 40% decrease in travel time thanks to the trail bridges that's in effect. And we've done on the ground research over several years to measure really the impact that these bridge sites are having on communities. And we're, you know, as we speak, really trying to connect that with our data. So you can click into any geography here and look at the impacts that these bridges are having with the travel time to different destinations. But let's say we really want to get more in depth, and we want to plan some new bridge projects, but we really want to focus on where we could improve female education outcomes. So some of that data we use in our models. And again, we're a big believer in showing communities and showing the public data that we use to make decisions so that everyone has access to it. So if you look at this here, let's look at demographics, and we're going to look at female education across Rwanda. So let's go to an area where we're seeing poor relative education levels, this red area. As you can see in Kigali, it's pretty good, and some of the patches of cities. Let's go into maybe this area here. So let's look at this area, and where are we seeing high impact from Trailbridge locations? Here we're seeing a good impact. Here's a good candidate. So we just found this is an area where we're seeing less female education outcomes than its neighbors across Rwanda. With a bridge or without a bridge, it takes almost 2 hours of travel. With a bridge, about an hour of walking time. This could be a bridge to prioritize if it wasn't already built for this community. And then, of course, then we get our boots on the ground out there to assess. And so this is the premise of what we've developed, how we've combined all of our research and models so far. And the exciting news is we have more coming, and I'll talk more about this in just a moment, but I'm going to kind of summarize what I've said to date, and I'm going to share these slides again. Okay, so remember, this is the slide we had before. We're closing data gaps. We're looking at where waterways are around the world. We've done that. We've built models to help support our applications. And we have built all of this into interactive applications that are available to the public and decision makers to help make better decisions about building rural infrastructure. There are outstanding questions we still want to answer. We want to give voice to rural communities and build applications that allow them to report their needs, as well as use satellite imagery and other data to predict where these bridges are needed around the world. Some of the things we've got planned include that prototype I shared for Rwanda, but across all or most of Eastern Africa. You can see it's in an interactive application. It's not quite done yet, but it's coming together, and the data itself is quite interesting to really look at. You can see it's just a large geographic area. but we use a lot of the same metrics, and eventually it'll be a similar application to what I shared for Rwanda, but for 7 countries across Africa, including Cote d'Ivoire. The other things we have planned, Erica mentioned a lot of these, and we're doing a lot of these, but we want to connect our digital programs into existing aid projects. So when we see roads being built, we want to make sure that those are serving the rural communities as efficiently as possible. So we want to deploy these models alongside those projects more, and also go beyond bridges, right? Erica shared a lot of infrastructure we're supporting in the development of beyond just trail bridges. And we think that our digital tools can really support this as well. Okay, with that, I'm gonna hand it back to Ian to take over the mic. And I'd love to field some questions as well. I covered a lot in a small amount of time, so I'm sure there's some good questions out there.
Thanks, Cameron. If you want to stop sharing the screen at the moment, and you and Erica want to come online, and a reminder that keep typing your questions there, and we'll answer them as we go. Also, in a moment, I think Mark will put in a link to a survey about our webinar series, just so you can answer some things there, and also picking up whether there are further topics you want in the future. And I'll just add to that, at any point, if you come across a good idea and you want to share it, just reach out. We can put my email address in there, or anyone in the ADB, and we'll certainly deal with that. I guess just picking up on the bridges, Erica, how have you found, like, after they've been built, the actual the taking ownership and the responsibility for maintaining them? Has that been easy to pass across, whether that's to the local community or to the local public works department? How have the locals, whether that's local or national locals, adopted those?
Yeah, great question. It's not easy. I think maintenance on infrastructure around the world is a major problem. It's not as exciting to invest in as new infrastructure. So it's not an easy issue, but we do think about this and tackle it in a few different ways. Number one, we work to train the local community. So usually, especially when we're building, but also we encourage when we're working with private sector, we encourage that the casual labor for the construction, because all of these technologies are labor-based. So we encourage local hiring of the community so that they learn as, the bridge is being built, how it works. And then the community always has a kind of bridge committee to represent the interests of the community during the project, because these are very community, based projects. And we always have technical people like carpenters, masons on those committees. And at the end of the project, we do training on simple maintenance with the bridge committee, the local community. One, so that if it's a small issue, they can address it themselves. Two, so that they know what to look for, so that they can be able to communicate to us or their local government institution and ask for support. So that's one way. Two, we try to really engineer the technologies that we use to be as low maintenance as possible. So we used to use timber decks for our bridges, pressure treated timber. But years ago, we switched to all steel and galvanized steel, just to reduce the maintenance needs. And third, as part of the work with government institutions, we set up local training programs, often through a quasi-governmental training institution. And inspection and maintenance is one of the modules that we teach, and do that with our government partners. So, and then we do that training in a very tangible way too, bringing them to bridge sites, and kind of walking through that together. And then, helping them plan for the future on, how can they think about this budgeting and planning to make sure that, they're accounting for it in the future, making sure it's included in how they're currently tracking their assets, inspecting their assets, trying to make sure it's integrated. So.
Cameron, so I see there's some questions here. We'll get on to the other people's questions, but this is the fun bit of being the moderator. You get your own ones first. So if I was working on a major road project in an area, I've got my corridor, and maybe I've convinced the funders to say, hey, we're willing to fund 10 trail bridges in this area. Is the system now at that stage where you can say, well, along this maybe 100-kilometre corridor, here is the best, the highest priority 10. Is that sort of where you're at, easily done these days?
Yeah, exactly, Ian. And that's really where we see there could be a lot of a good use for these models. And there, just to kind of call this out though, you did mention like two things. Like one is like, where do you put those bridges? The other is like, where's the best place for those bridges? Like, where would be the highest impact? And I want to really call out our human-centric approach here. Like, we are never going to just be putting a bridge where an AI model tells us. We're trying to use the AI to get our people to these areas in the most efficient way possible to make best use of their time. So what our model could tell you is we think that these communities would most benefit, and they probably know where to put the trail bridge. And I think that's, again, going back to our mission here at B2P, which is just giving voice to these rural communities. And but yes, to what you said is generally correct. If you give us a road and you say we got 15 spots for trail bridges, I think we could show you the best 15 places, more or less, or at least the best 15 communities to talk to.
Okay, I'm going to pick up Hamish's comment here. To what extent is this impressive and valuable tool integrated with government planning processes in Rwanda?
Yeah, that's a great question. We have been working in Rwanda for a long time and have really good relationships. It's a very decentralized country. So a lot of the decision making, happens on the lower levels of government, where they're collecting information from the communities and kind of prioritizing based on what the communities say their needs are. But we also work on the national level. And so these tools we've started using more so at the beginning. Obviously, we're still in the development phase. Like, there's still a lot happening with the development of these tools, but we really worked with our partners in Rwanda to get feedback and help us make sure we're making the right tools to be useful to them. And think through some of their use cases, the current asset management systems that they have in place, how they currently make decisions. They've had a lot of flooding in the last few years, and so they have a big push for climate resilience. And so, yeah, talking with them about how these models could help prioritize some of those areas. So they're not fully running with it yet, but we're kind of working together to make sure that we're working in that direction.
Thank you.
I also want to call
I'll
out, because we've done so much work in Rwanda, we're using Rwanda as a test case more so because we're very confident that we've answered some of these questions there. Like, we've sent human assessors to many, if not all, the potential trail bridge locations across Rwanda. So we actually use a lot of the Rwanda applications and data to train for other countries. So really the question I want is how fast can we get other countries' governments onto this?
I'll pick up a couple of Gordon's questions here. Gordon's very heavily involved in the Green Roads process. So he's asking quite intelligent, well-informed insider knowledge to the question. So a couple there. Ones, Erica, you mentioned community road empowerment. Is that similar to community-based maintenance? Is that just...
Yeah, Community Road Empowerment is an NGO we work with in Uganda that focuses on spot improvements of the road network. So they use different type of technology. So very similar to us, where we mostly work on the river crossings. They work on the not at a river crossing, but just a bad spot of a rural road.
So they're doing sort of filling the potholes, cleaning the drains type things, or they actually
Yes,
fixing the road itself? They actually get
exactly.
more into the, okay,
Exactly.
okay. So
Yeah, and
an entity as
they've tried to
opposed
be
an approach.
innovative too about like how to, again, make it less maintenance needs, very labor-based, community-based. They have a technology that they call Dunu, which uses like sacks that they stuff with different material, and they work with community to kind of layer those, and it's a bit more robust than just sometimes filling potholes manually in rural areas, and that can get washed away really quickly. So they're also trying to be really innovative and thoughtful about being low maintenance.
And then there's another question there from Gordon. For the bridge locations, are geologists and engineers involved in the bridge location and foundation conditions? I guess it's sort of how robust and generic are the designs, or do you still have to get very much
That sounds like a
specific designs?
good part two. Erica, you can answer this too. We've got some terrific engineers, civil engineers that work here at Bridges to Prosperity. They not only are intimately involved with the construction and site selection, but they also have really developed designs that are really leading edge on how to do this most cost effectively and safely. Erica, you can mention more about that if you want.
Yeah, and just to add on to that and what we were saying earlier, Cameron, about how these tools don't replace human involvement and actually visiting those sites. Yeah, we definitely do send teams to the ground and work with training programs to develop that capacity of local private sector and government as well. Because yeah, that actually the center line location, so not only where on the river, but also where are you positioning that bridge is really critical. And so it definitely does require technical people on the ground to choose that center line. And we do make our designs as kind of simple as possible and iterated at different span lengths and everything to make it as cost effective and simple as possible. But it does require definitely, a technical person at the site to look at the span, look at the high water levels, do some simple soil tests, choose the center line. It definitely does take still a little bit of technical expertise.
Question here from Simon. To what extent are the remotely sensed findings verified on site, such as the routes that people currently walk, the feasibility of potential bridge sites, and passability of steep cliffs, etc.? And I guess going hand in hand with that was my own thinking of what is it that the locals can do in terms of improving data sets to help this? Is this like when you're running something globally, is there an ability for locals to influence the global data set? How does that sort of interface work?
Yeah, great question. And a great setup. So first of all, how do you ground truth, or how do you check your findings? The data we produce. So again, the data we use comes from a variety of sources that we vet to go into our models. Open source, Erica walking into governments, grabbing papers, whatever it takes to get the data we need for the models, we use that. For our output on our data, the reason we're doing these projects is because we are well qualified to check our findings and to train our models with data we've produced. So we have people walking around asking communities where they need bridges, right? We have programs in Uganda, Rwanda, Kenya, in these places, Ethiopia, and we have people walking around asking people where the bridges are needed. We're using that data to double check our what we produce. We also have some in-house teams that check some of our like river generation models that are comparing that to satellite imagery. Of course, we're doing our own checks. So anyway, the long story short, we do take our data very seriously as far as it being correct. But as we get closer to real life infrastructure, we vet it more and more, right? So our walking paths, for instance, those are probably the fidelity on those isn't perfect, right? They're going to be off by several meters. It may not even be necessarily the path that a person walks, but we just needed to make sure that time was a consistent, rounded number close to the travel time. If we're going to check if a bridge is necessary in a place, that has to be true. So we, double check that a lot more. Going back to how rural communities can contribute to this data, we actually are in the process of building out a product called Fika Collect, which is a hybrid WhatsApp app and Android application that allow rural communities to report infrastructure needs. And we plan to roll that out with partners and governments in the next several months, and allow communities to really report their needs. And then we'll collect those and use them in our models.
Excellent. As I said, we've got time for one more question. From Dishan here, how do you assess the efficacy that developed rural roads, bridges and waterways? And again, who maintains the established rural waterways?
Good question. So I think the as far as waterways go, these are natural waterways. So no one maintains the waterway. The bridges we build with a 50-year lifespan in mind, but the governments we work with are often responsible for the maintenance. But we do everything in our power, like Erica was saying, to make sure that they are as low maintenance as possible. How do you, and then kind of the core question, how do you assess the efficacy of the rural roads and bridges we built? I shared some of our impact model, right, in that map, but we also have done extensive on-the-ground surveys for years with these communities, giving us real units behind these impact numbers. So we can look at education impacts, health impacts, economic impacts. And we've published research papers on that as well.
One last question from me. In many parts of the world, even where I live myself, many of these waterways would be dry for large parts of the year. And then, nowadays with climate change, we're seeing, a lot, long dry spells, then heavy floods. How do you build that into your models? Like or is it even practical to sort of say, well, this bridge we could build here is going to do nothing for 90% of the year, but the other 10% of the year is going to be absolutely critical. How do you work that in? Or is that sort of version 2.0?
Yeah, it's a good question. We've done research on that question fundamentally. Like, is there a relationship between flooded days and impact? For instance, if it's flooded 100 days, is that going to show more impact than if it's flooded for 5 days or 10 days? That relationship's not as strong as you'd think. Of course, if something is flooded more, it's going to be more of an inconvenience. But there are other variables that really play into it more than flooded days. And we also, consider it to be a human right, access to be a human right for these rural communities. And so even if it is only flooded a few days, what happens if that's right when you need to bring your cash crop to market, right? Like that really matters.
Yeah.
And we've done research on other variables you can look at that can give you more of an idea of how to prioritize some of these sites. But that's some of our thinking behind that.
That's really good. And I guess we're very much at time. So I would like to thank you both for giving us a great presentation. I think that by the fact we're getting questions and continue to get questions, I just check there's no, I think Gordon's summed it up there. Sounds like an amazing program. Thank you. But nothing else there. Urgently needs responding. I'd like to thank you again for taking the time. Wish you all the very best with it. Hopefully we'll see a database at some point where all the bridges are there and people can register that they've inspected it once a year or whatever it happens to be. Happy to have a chat with you on that sort of idea. Be a really nice little thing to know that these are going on and giving long-term service to the community. So thank you. Keep up the good work and look forward to talking to you again soon. So I'll give you the virtual clap and thank you everyone for joining us.
Thanks so much.
Thanks,
It was a
Ian. Thanks,
pleasure.
Rebecca. Really appreciate being here. And anyone reach out to us if you have questions that we didn't get to. I always love talking to infrastructure people like the folks on this call.
Thank you very
Thank you,
much.
everyone.